Hello algebra students and seekers of truth. In this video we are going to study different types of variation, direct variation, inverse variation, and a third category called joint variation. And this concept isn't too difficult. It's really about understanding vocabulary and applying it successfully. So let's get right to it. So a direct variation is two quantities, or you can think of as variables, that are a constant multiple of each other. So you can think of this as when one gets large, the other gets large as well. So here's an example. Y equals 3x. Okay. So we say that this is a direct variation because x and y, they're always off by a multiple of 3. So for example, if you were to make a table, x and y, if x is 1, then y is 3. If x is 5, then y is going to be 3 times 5, or 15. Okay? So whatever it is that you see in the left column, you multiply by the same number to get to the right column. Okay? Now you might see this being written in different ways. So you might see this is written as maybe 3, or y over 3 is equal to x, but just because it has a fraction or a division result here, it doesn't change anything. So for example, if I were to make my table again, and this time I use y as the input. So let's say that y was 9. Well, x would be 9 divided by 3, which is 3. Let's say that y was 3. Then x would be y divided by 3, 3 divided by 3, which is 1. What if y was 12? Then x would be 12 divided by 3, which is 4. And you can see here, going from the left to the right, you're always multiplying by 3. 3 times 3 is 9. 1 times 3 is 3. 4 times 3 is 12. Now, the number 3 here, we call this the constant of variation. Okay, so some important vocabulary words here. It's not always 3, it's not always 1/3. It can be some different numbers, but the point is that it's a constant. It's a constant multiple of each other. Okay, so let's contrast this idea with inverse variation. All right, so an inverse variation is two quantities or two variables that always have the same quotient. And you can think of this as say a way of saying when one of them gets large, the other gets small. So for example, if I say y is equal to 3 divided by x, notice here if I were to make a chart, let's say that I have x and let's say I have y. Let's say that x is equal to 1. Okay, so y is equal to 3 divided by 1, which is 3. What if x is equal to 3? Well, y would be equal to 3 divided by 3, which is 1. Okay. And now let's keep going. Let's pick a different number here, 5. Okay. If x was 5, then y would be 3 divided by x, which is 0.6. So notice here, as x is increasing or getting bigger, y is decreasing, getting smaller. So, and the other thing is that the quotient, if you were to divide the two of them though, if you were to take x and you divide it by y, so you did like, sorry, if you took y and divided by x, you would always get the same number. Okay? So that's the I'm sorry, if you were to multiply y and x, you would always get the same number. So if you were to multiply across 1 times 3, 3 times 1, 5 times 0.6, you would always get the same number. Now, we'll get to that numerical example a little bit more in a little bit more detail later. But here, and again, this is still called the constant of variation. And I'm using 3 here just as my example, although it does not always have to be 3. So now let's go forward and let's look at some of these examples here. Are these direct, inverse, or neither? Okay, so let's look at the first one. Y equals 4x minus 1. Now we can make a quick table, x and y, and let's put in some values for x. If x is 1, then y is 4 times 1 minus 1, which is 3. If x is 2, then y is 8 minus 1, which is 7. Let's say if x is 5, then this is going to be 19. Okay, so is this direct? inverse or neither. Okay. Well, are they the same? Are they always different? Let's look at the definition, right? Are the two quantities constant multiples of each other? So, 1 times something equals 3. Is that the same number as that you use for 2 times that same number to get 7? Okay, so here's a way to look at it. To contrast up here, let me change colors really quick. So if you look back up over here, if I wanted to go from 3 to 9, I'm always multiplying by 3, right? Times 3. If I want to go from 1 to 3, I'm multiplying by 3. If I go from 4 to 12, I'm multiplying by 3 again. But here, down here, if I wanted to go from 1 to 3, I'd multiply by 3. That's nice. Going from 2 to 7, I'm multiplying by 3.5. And going from 5 to 19, this is 3.8. Okay? So because I'm not using the same number every time, the first example here is neither. Because the two variables they are not the same. They are not the same multiple. If you look at number 2, though, well, they are. This is a direct variation. It is a direct variation because we can put in some numbers. We can see that 1 here for x gives you 5 for y, 2 for x gives you 10 for y, 5 for x gives you 25 for y. And when you're going from 1 to 5, you're multiplying by 5. Going from 2 to 10, you're multiplying by 5. Going from 5 to 25, again, you are multiplying by 5. Okay? So one way to identify that something is a direct variation, you can think of it as it's like a linear function without any y-intercept. Okay? So first it has to be a linear function, remember those, and there's no y-intercept. That makes it a direct variation. In number 3, is this a direct inverse or neither? Well, in this case, you can see that it's going to be a inverse case. So I can just do a little bit of algebra with this. So if I have 1 over y equals 2x, I can multiply both sides by y. I get 1 equals 2xy. And then I can divide the other side by I can divide the other side by 2, so I get 1/2 is equal to x times y. Okay? And so you can see here that no matter what I do, when I multiply x and y together, I'm always going to end up with 1/2. So that it's always going to have, when I multiply them together, I'm always going to have the same result. And when one of them gets bigger, the other is going to get smaller. I realize now as I'm talking that I made a mistake in the vocabulary here. So this second statement here is really poorly worded. It's two quantities that always have the same product. Okay, product. When one of them gets bigger, the other is going to get smaller. But when you multiply them together, you're always going to have the same result. Okay, so in this case, in this third case here, this is called an inverse relation. All right, so let's end this right here, and then let's take up the next examples in another video.